Hello, this is Mr. Lima again with a workshop video for angles, triangles, and prisms. This is to help students pass the content assessment in Summit platform for 7th grade math. Now, even if you're not using Summit, this could be useful for you because it's basically going to review types of angles and areas for polygons and also surface area and volume for prisms, at least the parts that a 7th grader needs to know. So this is not meant as a teaching video where I go through each of the skills in detail. It's meant as a review video for someone who already knows kind of how to do it and just needs a last push review before taking a test. So I strongly recommend that if you do not know how to do these skills, that you watch the other videos that I put together where I teach the content in detail. This is more of a practice video. So the first objective is to recognize the properties of supplementary, complementary, vertical, and right angles, and also know how to classify things like acute, obtuse, and straight and right angles, because you need those in order to understand the others. So in the first problem here, I have some angles that need to be named as acute, straight, obtuse, or right angles. So go ahead and try to do that and pause the video before you continue, but also try to do number 2, which is the one that has names that you have to then draw the angles instead, and figure out if you're right, and also define what each of those angles mean with words. Okay, so let's try to do that. Pause it. Hopefully you were wise and pause the video before I reveal the answers, and here they are. So this is a straight angle because it's a straight line with an angle around it, right? So 180 degrees. And then this is a right angle because it has that little boxy mark representing the fact that this is exactly 90 degrees. These two are obtuse because they're bigger than the right, but not quite as big as the straight. And so is this last one right here. All right, so if it's bigger than the right, but not quite as big as the straight, it's obtuse. All right, bigger than 90, not quite 180. Acute angles are smaller than your right angle, so these two are going to be acute. And here's another right angle, even though it's upside down, because it has a little box marking exactly 90 degrees. All right, so on this side, we have the names, and we have to draw them. So here's an acute angle because it's less than 90. An obtuse is more than 90. Technically, you should also say that it's less than 180 in order to be called obtuse. Straight is exactly 180. Right is exactly 90. Then we have the idea of complementary angles, and those are the angles that add up to 90 degrees. Their sum is 90. So they're made up of a right angle split into 2 angles. And then the same thing with a supplementary, except it's up to 180. So 2 angles, which add up to a total of 180, or a straight angle. Vertical angles are angles that are opposite to each other across a set of intersecting lines. So you can't really see the angles marked very well, but this one and this one would be considered equivalent vertical angles, as would be that one and that one, because they are also opposite the vertex across 2 intersecting lines. So, and then we have adjacent angles, which are angles that share a vertex and a side or an arm or a ray. Okay, so then these will be classified because they are 2 angles that are adjacent to each other, touching each other, sharing that arm and that vertex. By the way, all complementary and supplementary angles are by definition supplementary, complementary angles are going to be adjacent because they're a set of 2 angles that add up to that. All right, so we're going to go back here to the questions now. This time we have a different kind of question where we have problems. You have to figure out what the missing angle is. So that's another kind of question you will see to test. But the secret here is to use those relationships, recognize when the angles are complementary, and then that means they must be adding up to 90. So you do 90 minus the angle you have to figure out the difference. Same thing with supplementary angles. You got to do 180 minus the angle you have to figure out what the difference is. And for vertical angles, you just remember that they're the same across the vertex. And then using those skills, try to figure out all the missing angles in the picture. By the way, this one right here is kind of hard to see. It's a 12. So make sure that you pause the video before you try it so that you don't use the opportunity to actually practice. Okay, so hopefully you pause the video. So here are the answers for that. Okay, so let's go through each one of them and understand why. So these are supplementary angles because they add up to 180 in a straight line. So this must be 62 because then add it to 118, it makes 180. The way you figure it out is 62 is you do 180 minus 118, and then you get 62. Likewise, supplementary angles on this one. So 180 minus the 77 you get gives you 103. So that was another example of that. Here's another one with supplementary angles. So that was 180 minus the 50 you have gives you 130 degrees for the angle that's missing. All right, so how about this one here, the complementary angle? Because they're making a right angle, I can assume then that this is going to be 15 because added to the 75, it will make a total of 90 or a right angle. All right, so we have another example of that here, complementary angles, because this one is 12, so then this one must be 78. So it adds up to 90 total. So you just do 90 minus 12 to get that number. Here's another complementary angle problem right here. And that one was 53 because 53 plus 37 gives you 90, right? So that's essentially how you do it. Subtract the one you have from 90 to get the one you're missing. And then we have the ones with vertical angles. So this one has the same angle as that one because it's a vertical angle sharing a vertex on opposite sides of intersecting lines. So it must also be 133. By the way, you could figure out what the little guys are as well. It didn't ask for it, but if you wanted to, knowing that these two are sharing a straight angle, right? So that means if this is 133, that has to be the difference between 133 and 180. So if you do 180 minus 133, you should get your answer, which should be 47, if I'm not mistaken. 7 makes 40 plus 40, 180, yes. So 47, which means this side is also 47 because it's a vertical angle with that. And that's kind of what I did over here to figure out all the missing angles. If I know this is 76, then this must also be 76 because it's a vertical angle with the one that was 76. Now, this one and this one are supplementary. So it must be 104 so that x plus 76 makes 180. And since z and x are vertical angles across the thing, it also must be 104. And that's how I figured out all of these missing angles and problems. There's one more vertical angle here. So let's try that. That's 35. So the opposite one is also going to be 35. And once again, even though it's not asking for it, I'm going to practice it. If this is 35 and these share a straight angle, there must be supplementary. So they must be adding up to 180. 5 makes 40. 145 will add to 180. And that means this side is also 145 because it's a vertical angle with that one. And I think that's it. I think I went through all of them. So now let's go back to the practice and look for another kind of problem that's going to show up in the test. And this is the ones where you are given an angle or a number, and you have to figure out what is the supplementary and complementary angles to that. So now remember, complementaries have to add up to 90, so you do 90 minus the number you have, and supplementary must add up to 180, so you do 180 minus the angle you have to get it. Whether they give you in a picture or they give you the numbers on the side, the principle to try to do it is the same. So let's go ahead and try 4 and 5, pause it before trying the next one. So hopefully you are wise enough to pause it, and let's go into our video. So in here we have the answers. So this is 62, 28 will be complementary to it, making 90, and 118 will be supplementary with it, making 180. 54 plus 36 makes 90, plus 126 makes 180. So that's the complementary and supplementary. So it's all the same thing. You just got to do 90 minus the angle, 48, to get 42 for complementary. 180 minus the angle to get 132 for the supplementary. 90 minus 12 to get, this is supposed to be 78. There's a typo over here. So this is supposed to be 78 as the complementary. And then for the supplementary angle, since this is 12, it's actually supposed to be 168. There's a typo there. For some reason, I thought it was 20, and then it caused a mistake. So 178 and 168 on those two. And then here we have 19s, which completes 71 to make 90, or 109 plus 71 to make 180 for the supplementary angle. 23 plus 67 will give you, 70, 20, 90. And 113 will give you 180 minus 67 gives you 113. So there you have it. This is if you're given the angles. Same idea with the numbers. 84 plus 6 makes 90, so complementary. Plus 96 makes 180, so that's the supplementary. 42 plus 48 makes 90, so that's the complementary. And if you do 180 minus 42, you get 138 for your supplementary. And that's how you answer those. You just have to subtract from 90 to get the complementary, subtract from 180 to get the supplementary angle. So the last set of problems for the angles is, given a picture of certain angles, name the angles, which would be vertical angles or complementary angles or supplementary angles to each other. So there's a lot of possible answers in here, and you should pause before I reveal it, right? Well, here's a reveal for that. There's a lot of possible answers. But as you can see, let me just mark them for you here. So this angle and this angle are going to be complementary, and I think that's the only complementary pair we have, and it's BXC together with CXD, right? And there's the angle little symbol there for you. Then as far as supplementary angles are concerned, if you get this big angle right here and this angle right here, technically they're supplementary. So that's BXD together with AXB are going to be supplementary angles. And they're both going to be 90 in that case, right? If this is truly a right angle here, which it says it is. All right, moving on to the next picture. This angle and this angle are going to be supplementary. So EYG and GYH. But you can also make supplementary pairs in a variety of other ways. You can combine that angle with this angle. You can combine this angle with that angle, or this angle with that angle. All of those are adding up to 180, right? Because you have 180 here, you have 180 here, you have, okay, let me erase so you can see what I'm talking about. I'm going to erase each time. So you have this 180, different color. You have this 180, so those are supplementary angles. You have this 180, and you have this 180. So there's 4 sets of 180s you can create, and that's why there's so many supplementary angles using the second picture. As far as vertical angles, erase so we can see them, we have this one paired up with this one, and this one paired up with this one. So that's EYG and GYH. No, sorry, EYG and FYH, and then EYF with GYG, right? So that's like the vertical angles. And there you have it. We have reviewed in this video the skills associated with objective 1 so far of the of this test. But there's also a second objective, which has to do with figuring out the areas of figures. So going back to this right here, we're going to start with areas for two-dimensional pictures. Now, these are both trapezoids. Now, remember, when you're finding areas of trapezoids, is 1/2 the base plus the other base, so in other words, the average of the bases, times the height. And the bases are going to be the parallel sides, and the height is the one that connects them. So in this case, the 6 and the 9 are bases, and the 3 is the height. You can figure out the same kind of thing for this one. Try to figure out the area of that. For the triangle, it's just 1/2 base times height, and you can basically figure that out using the numbers given to you, and try those before I actually show the answers. All right, so here we have the answers for the first set of problems. I do not show every step of the order of operations, especially since you can use calculators in this test. But to avoid the errors when you are doing the work, you should do all the steps, just like when you're doing practice, and do one step at a time to avoid making mistakes. All right, so over here, we have the first one. It's the average of the bases. So if you have one base that's 6 plus one base that's 9 divided by 2 times the height, right? And that's the same thing as 15 divided by 2 times 3, which is 22.5 inches squared, because we're doing a two-dimensional thing. Over here, the bases cannot be 10 and 11, right? It's not always the ones vertically. It's the ones that are parallel. And these two lines here aren't parallel. So you're going to use the 10 and the 5. 10 plus 5 divided by 2. And then the height will be the line that connects them, right? So this connects them, but it's not a right angle. So I should say the height makes a right angle with the bases and connects them, right? So then you go, 10 plus 5 divided by 2 times 10. That's 15 divided by 2 times 10, which is the same thing as 75. And if there were units, they would be squared as well. Okay. Last one, 1/2 base times height. So half the base is 12 divided by 2 times the height is 4. So that is 6 times 4, which is 24. And again, if there were units, they would be squared because it is a two-dimensional quantity area. And there you have it. That's pretty much how you do it with two-dimensional objects. Now, why am I skipping the rectangles? Because you have to do that when we do the volume, and they're essentially much easier as just base times height. But we're going to see that when we do the volumes of prisms, so we're going to need that. Speaking of which, so here we have 2 sets of prisms. 2 of them are boxes, and 2 of them are triangular prisms. Now remember, in general, the surface area of a prism is found by adding up the areas of all the sides. And the volume of a prism is the base times the height. Now, the base can be any side that has a paired side. So in a box, any of the sides can be the base. And the height is going to be the one that connects the two, making a right degree angle with it, right? But on the triangular prism, it's very clear that the base has to be this triangular part because it's the only paired sides that have a right angle connection between them like that. So that's what we're going to call the base. You can't call this one and this one right here and this one the bases because they're not parallel to each other, right? They're like this. But the two triangles are parallel on opposite sides connected by a height. And so the triangles will be the base and this will be the height. So using that, you figured out the area of the base by figuring out the area of the triangle and multiply times the height. Or in this case, the area of this base, right, times the height. And that's all there is to it for volume. For surface area, you have to break down side by side of the figure. So go ahead and try to do that. And I will review the answers for the first 2 problems here in a second. All right, so here's the answers for the first 2 problems. And again, I'm not showing orders of operations. It is important that you practice that when you're doing your practice or use a calculator to be careful. And in fact, when I'm doing surface area, I will probably figure out the area of each side separately and then add them all up. It's a better way to not make mistakes than trying to write an expression like I did. But what did I do? I did 12 times 8 to figure out the area of this side, but then I realized there was another area just like it in the back. Now, if you are doing step by step to not make mistakes, you can just figure that out, which 12 times 8 is going to give you 96. So the area of this is 96, but you got 2 of them. So you got 2 96s already, one on the front and the one on the back side of it. And then you have this one right here, which is 8 times 4, and that's the area of that base or the area of the top, right? So 8 times 3/4, and that's 8 divided by 4 is 2 times 3 is 6, but you got 2 of those. You got the top and you got the bottom. So you got 6 and another 6 with that. So whenever you have boxes, you're going to always have pair sides. The last one you have is this side, the darker one, that's 3.4 by 12, right? Remember, this height is also 12. So 12 divided by 4 is 3, times 3 is 9. But again, you have 2 of those because you have one on this side and one on the opposite side. So you can't see it. All right? So then you can just add them all up and figure out what your total is. And if you did that, you would also get 222. And remember, you can use calculators. So you can just do 6 plus 9 plus 9 plus 96 plus 96 and get your answer. Or you can write an expression like this and work it out. Whichever way you do it, make sure you do it carefully so you find your answer. For volume, I just multiplied 12 times 8 times 3/4, and that gives you 72. Now, when you do the same process with the surface area of this prism, you have to start with the 2 triangles. So that is a base of 8, half times the height of 3. But there's 2 of those. So that's 8 divided by 2, which is 4 times 3 is 12. But there's 2 of those. So you have 2 triangles, which are 12. And that's what I'm trying to do here in the expression. 2 sets of those. But then you have 2 sets of this side right here, which is like the inclined side, which is 5, right? See the mark that's showing us the same? 5 by 12. 5 by 12 is just 60, but you have 2 of those. So you have 60 and another 60. And that's why in the expression, I wrote 2 times those sides. All right? And then you have the side at the bottom here, which is 8 by 12. And again, 8 by 12 is 96. So you have that last one. Add all of these up, you get 240. Or if you do the expression and do it carefully, whichever way you do it. But I like to make sure to figure out the area of each side and just add them up. Less mistakes than trying to do it through the expression. So I'm showing you both ways. Then you also have the volume, area of the base. Remember, the base is the part that connects it times the height. So when you do that, you're going to do the area of the base, which is the triangle. So 8 divided by 2 times 3. So that's going to be 12 times the height, which is also 12. So that's 144 centimeters cubed. Notice that the unit is cubed for volume and squared for area, because this is a two-dimensional quantity and this is a three-dimensional quantity. All right, we got more practice coming our way to finish up the video. We got 2 more of these. So if I did the first one for you and you couldn't get it right, now maybe you can figure out how to do it and try it again to see if you do it right. Pause before I show you the answers. Okay, so here's another set of them. And again, for the surface of the box, all you have to do for the surface area is figure out the area of each side. And then remember, there's pairings on the box. So this front side here, it should be 12 times 6, which is 72. But you got two 72s because you also have the one in the back side. Then you have this side right here, which is a 6 times 15, right? So 6 times 15 is, let's see, 60 plus 30, so that's 90, I think. Nope, wait. Yeah, 60 plus 30 is 90. So, but you got 2 of those because you got this side and the opposite side. So you got 2 sets of 90s over here. And then that's what I'm writing right here. Everything multiplied times 2, right? And you got the 6 times 12. Well, that's no, we already did that one. Sorry. The 15 times 12, because that's the bottom and the top. 15 times 12, the bottom and the top. 15 times 12, you put that in a calculator or do it on your own. 5 times 2 is 10. 1 carries over. 5 with the 1 that carried over is 6. And then 0 here. 2 and 1. Seems like the answer is 180. But there's 2 sets of 180s because there's one on the top and one on the bottom. And then you just add all those up. 2 180s, 2 90s, and 2 72s to get your final answer, 684. Or do it with the expression and follow order of operations carefully. For the volume, you just multiply all of those dimensions, and that is actually incorrect over here. I don't know why, so let's fix it right now. 12 times 15 times 6 is what you need to do. And when you do that, in a calculator, you get 1,080 inches cubed because it's a volume, it's a three-dimensional thing. And of course, the surface area is in inches squared. All right, so same kind of thing with this figure, except you have to figure out each of the sides. So we'll start by identifying our base, and that's this side right here, because it has a pair side that has a parallel to it, right? So I'm going to call that one the base. You could actually see that. So this is the triangle that I'm calling the base, right? And of course, the area of that is going to be 12 divided by 2, which is 6, times 16. And then if you multiply that times 10, you get the volume, and that's 960. Or basically just multiplying each dimension by itself, all right? It's essentially what you're doing, except the dimensions of the base are triangular. So that's why you have to divide it by 2. Okay, so 1/2 of the base times the height of the triangle gives you the area of the base, which is this part right here. And you need to multiply times the height, which is this part right here, get 960. Now for the surface area, you have 2 sets of triangles, and that's the same thing we did right there to figure out the area of the triangle. And you have 2 of those. But then you have one set that is 16 times 10, and that's this box in the back here, the rectangular box that's 16 times 10. You have one set that's 10 times 20, and that is this box right there, the big one on this side. And then you have one box that's 12 times 10, which so many of them trace, it's kind of hard to tell which one I'm talking about. So it's race, which would be this box right here. Now add all of those surfaces together and you get 672 centimeters squared. Squared because it's area, and the volume is cubed because it is a three-dimensional structure. And that, my friends, is how you do this. Happy to help. There's more practice available in the Power Focus area. Take advantage of that, including another workshop video like this on more problems like the test. So take advantage of those and don't do anything that won't make you more proud. I'll see you on the next lecture series.